time. Okay. Okay, good.
It's Kendria. I need to go over 19.
Okay,
On
Kendria.
how much? Yes.
Come on, let me get to that point. Let's cover some other stuff first. All right. Okay, good. All right. Hang on, let me make sure I got my thing all centered here. Okay, good. So a couple of administrative announcements. If you're adding any course in the San Diego Community College District, the last day to add is Friday. So they accept absolutely no late adds. So you want to make sure you add by Friday. Okay.
Is that by midnight Friday or midnight Thursday?
Just do it by Friday.
Okay.
Friday is the last day to add.
Okay.
What time on that day? I don't know. The end of working hours, I would assume.
Got it.
But just do it by Friday. You're good to go. Okay. Do it tonight after we finish class. All right. Oh dear. Let's see. Oh, good to see you here too, Dakota. I'm glad you showed up. Yeah, don't forget to add.
Yeah, thank you very much for the code.
All right, let's see. What else we got? Other administrative announcements. So I'm going to do office hours tomorrow from 6 to 6:50. Okay. And I'll put out an email. I'll put that out on the email, which I send you tonight also. And the office hours will be right here at the same Zoom room, right here at 6 to 6:50. Okay, let's see. What else? Other administrative announcements. Okay, several people have asked, when will we be back in the class? When will we be back in the classroom? And we will be back in the classroom on week number 4, which is the 23rd of February. Okay, that's a Wednesday of that week. So Monday of that week is a holiday. There's no class on that day. So that's a federal holiday. That's they got it listed as Washington's Day. So it's basically it's President's Day on that Monday. The Friday before that is also a holiday in the San Diego Community College District. So if you have a class on that Friday, that's also no school on that date. Now let's see. So I have it listed as for test 1 on that day. So I'm strongly leaning towards pushing that to the following Monday. Just because the way things are split apart here, everything is goofy. And I want to make sure, since we're covering more than I would normally cover on test 1, I want to make sure we got some extra time to do review and answer questions. But again, I will solidify that by email. So I will send you out an email to that effect. So everybody should be getting my emails okay. My nightly emails with the video and the homework on it. And
yes, sir. It works perfectly fine.
Good. And I sent another video out today with the
the flyers.
Hand out the flyers for the peer
navigation.
The peer navigation, yes, the peer navigation program. Okay. Which I actually worked with that a couple of years ago, and it was a lot of fun during the summer. So, and it's a paid. I mean, I didn't get paid anything for it. It's just volunteer for my part. But the students that participated, the peer navigators, were paid, so that's a good deal. Let's see what else, and that could continue throughout the year. There's certain criteria that are on those flyers that I put out, and points of contact, and they're having a meeting. I believe it's on February 17th. So they're having a Zoom meeting to give more information on it if you're interested. I'll get more information on that date too, because I wasn't too clear when I read the flyer if that was actually the date and what the Zoom link was. But I'll find out that information and get it to you. So that's on the, I believe, the 17th. So today's the 9th. Okay, let's see what else. Let's see. Don't forget, next Monday is Valentine's Day, but that's not a holiday in the San Diego Community College District. But we will have class on that day. Let's see, any other administrative announcements? I can't think of anything else right now. We got a lot to cover, so let's get right into it here and do a quick review of what we covered last time. And then we'll answer any homework questions. So I know Kendria had a homework question, so we'll answer that. So we started off here. Let me get down here. In 8.3, talking about two variable system word problems. So a word problem where you're going to end up with two variables, build a system, and then solve the system. So we looked at a couple of different ways to do that. So we looked at the pure number problem. Okay, and there we saw we use keywords to translate into sentences, which we can then change into an equation, just one for one, sentence to an equation, subject, verb, object, left side equation, equal sign, right side of the equation. Okay, and then we looked at different types of mixture problems. So the first one was a value mixture problem. There we're going to make a table and use this relationship. So I have the relationship is the cost is equal to the price times the amount, but I have it written in reverse order because that's how you want to put it at the top of the table. The price times the amount equals the cost. Or you want to put the amount first, that's okay too. Then we looked at interest mixture problem. So in an interest mixture problem, again, we can make a table. The equations fall right out of the table. And there the principal times the rate times the time is equal to the interest. The principal being how much you borrow or how much you invest, both of those things. And then we looked at a percent mixture problem. So again, make a table. The whole times the percent is equal to the part. So the part is equal to a percent of the whole. That's what that's based on. But again, but I have it in reversed order. And finally, Bella, what are you doing? I know, but you're in the road here. Come on. I'm going to hit you with my chair. That's my dog getting in the way. All right. So then we looked at the motion problem up at the top of this column over here. And there it helps. A lot of times it helps if you draw a picture because that helps you visualize the situation. And then we can make a table using the rate times the time equals the distance. And there we saw that a unique thing about that is the equations, instead of falling out vertically in the columns, they fall out horizontally in the rows. And it works out really well. Okay. But if you get used to doing that, especially if you go into more advanced mathematical courses, pre-calculus or Calc 1 and 2, where they have a little bit more sophisticated word problems, if you're into if you can understand this making a table technique, that's a real good method for simplifying the situation and organizing your work and seeing what the equations are. Okay, and that took us to the end of 5.2. Then we went, or 5.3, excuse me. Then we went into 8.3. Then we went into 8.4. Where now we're looking at solving a 3-variable system. So here's a system with 3 unknowns, and typically you have to have 3 equations. If you have 3 unknowns, you got to have 3 equations. If you have 2 unknowns, you have to have 2 equations. If I were to have 4 unknowns, 4 equations, and etc. The supercomputers can handle 100 unknowns and 100 equations. Okay, but that takes a lot of rapid thinking on the part of the supercomputer. Humans, not so much. So we won't go any further than a 3x3 system. So that's what it's called, a 3x3 system. So a couple of things we looked at here. So standard form is ax plus by plus cz is equal to d. The solution is an xyz, which we call an ordered triple. So in a 2x2 system, it's an XY ordered pair. So in a 3x3 system, it's an XYZ ordered triple. To check a solution, just like we did with a 2x2 system, you substitute, use parentheses to substitute, do the math. Okay, and if the left side equals the right side, then that whatever you're checking is a solution. So remember on the test, when I tell you to check if something is a solution, I do not want you to solve the system. I want you to check the solution. Okay, and that will be a question on the test to check to see if something is a solution. Note for one note on the 3x3 especially, you must check it in all three equations. So you have three equations, you got to check it in all three. Okay. Next page, please. Next side of the board. Here we go. Okay, so to solve a three variable system, what are we going to do? So this is the method here to solve a three variable system. So one, write the system in standard form. Okay, and part of that, number the equations. And you want to line up the x's, the y's, the z's, the equal signs, and the stuff on the right-hand side of the equal sign. So everything is lined up. That's an important aspect. So write the system in standard form. And then clear out any fractions or decimals. So it helps a lot if you get rid of the fractions or decimals, make everything whole numbers or integers. Then three, you eliminate one variable from two equations. So you look at your system and you see what would be the easiest variable to eliminate just by adding two of the equations together. Okay, and you want to pick that one and eliminate that variable. Then you eliminate the same variable from two other equations. Now, one of the equations can be the same in both of those eliminations, but you have to do like a different pair. Okay. And then five, that gives you a 2x2 system. So up here, you'll start with equations 1, 2, and 3. And then when I get my 2x2 system, I'll have equations 4 and 5, which is a 2x2 system, which I can then solve. So the 2x2 system, we have solution techniques for that. Then I'll get the solution for those two variables. Then I can use the original system equation to find the third variable. So you can use any other original system equation to find the third variable. And then always check it. Okay, so some notes over here on this side. So let's take a look at those. Notes. So number one, number your equations. Okay. Number two, work vertically. So that means instead of working like moving the system side by side, go up and down. And then if you reach the end of your paper, then start another column. That just makes it easier to track your work. Three, write what you do each time. So if you multiply an equation by 2 or 1/2, just say what you do over on the side, just like I've been doing. Then 4, you may have missing variables. So we'll see examples of that today where there's one or more of the variables is missing. And actually, that's a good thing. It makes it easier to solve. And then 5, check only in the original system. And 6, there's more than one way to solve these. Okay. So questions on homework problems. I know someone asked about number 19. So Kendria, is that 19 in what, 8.3? What's that?
Yes, sir. Page 527 is what I have.
Oh, okay, 527. Yeah. Let's see. 8.3, then number 19. Yes, okay.
Okay, so my problem is building the system for this.
Sure. To get in the system is always the hardest step.
Yes, okay, thank you. I'm going to be quiet and I need you to go slow and keep out of the way of the board.
Okay. Well, I'm afraid I can't make my head transparent. But
I
we'll try
know,
not to block too much of the board.
because I need to
Was
see
nice.
this tomorrow.
So let's read it. So I'm going to read this thing here, and it says, in 2007, solar, wind, and electricity generators generated 218,000 megawatts. Okay. Wind generated 2,000 megawatts. More than 7 times that generated by solar energy. Oh, okay. How much was generated by each source? Okay. So basically we got solar and we have wind, solar and wind. Okay. And they're each generating amount. Now, don't worry about the date. Nobody cares about that. Don't worry about megawatts. Nobody cares about that. All we care about is the basic numbers. So we have 218, and then we got 2, and then we have a relationship for the 2. Okay, good. So this is actually a variation of a number problem. We can work this just with keywords. All right. So let me turn around here and clean the board. Hang on. Good. Okay, good. Okay, so this is 8.3, number 19. And this is a type of mixture problem, but it's like a number mixture problem. There we go. Okay, so we read it. So we got these two sources of power, and they're both producing this total amount of energy, but then one produces sort of there's a relationship between the two of how much power is produced. Okay, so I just said it back in my own words. So I think I understand it. So let's look at it again. So it says there's solar and there's wind, and it says solar and wind totaled 218. So here, keyword total is an equal sign word. Solar and wind, solar plus wind equals 218. Okay, so that gives me an equation. So here, number 1, I got solar. I'll put S for solar for a variable, plus wind equals 218. Okay, so that's one equation. And that's just the sum of the two parts is equal to 218. If it's megawatts, I don't care. If it's thousands of megawatts, I care even less. All I care about is the raw numbers. Okay. Then we go. Now, the next one the next one puts a relationship between the two of them. And it says wind generated 2,000 more than 7 times solar. So let me put that in simple. I'm going to write the words up here so you'll be able to see the words. So we got wind is, instead of generated, I just put in is, because the verb is typically the equal sign word. So, you know, I don't care if it's is an easier word, and it's shorter for me to write. Okay, so wind is 2 more than 7 times solar. I think that's right. Wind is 2 more than 7 times solar. Okay. So you see what I did? All the key words. So notice, here's my equal sign word. That's my equal sign right there. And then I got here more than, that's a plus, addition. And then I got times, that's a multiplication. Okay. So from that directly, 1 for 1, using these two variables, S and W, I can make an equation. Watch. W is 2 more than 7 times S. So what I'll go, it goes 7S plus 2 more. So 7 times solar plus 2 more. Okay. So now I have my second equation. That's where you're having the problem, is coming up with the system. So did that make sense how we came up with that one?
Yeah, of course. The is, the more, okay, thank you.
Okay, good. And then from there, you can see from there, it's pretty straightforward. This one is set up to solve itself by substitution. Okay, how about any other problems on other homework problems? No, yes, no.
46.
Okay, and 8.3. Yes, I know it's 8.3. Okay, 46. Let's take a look at that one. Okay,
I
good.
felt
This is good because this is a motion problem.
I couldn't come up with two equations. I just got one equation.
All right, well, let's take a look at it. So it says 2 cars. Oh, right away, I got 2 cars. And they leave Salt Lake City. Here, let me come over here so you can see me reading this. So 2 cars leave Salt Lake City, traveling in opposite directions. Okay. 1 car travels at a speed of 80 kph, kilometers per hour. The other at 96 kph, kilometers per hour. In how many hours will they be 528 kilometers apart? So this one, drawing a picture of this one really helps you understand the situation. So let's go ahead and do that. So here, this is, 46. So 8.3, 46. We'll come up here. Okay, so here we got a motion problem. And so here we have Salt Lake City, right there, right in the middle, okay? And then I got 1 car going this way. Bob, there's the car. You can even draw, if you're really talented, you can draw little cars in there. There's 1 car. And then 1 goes this way, da, 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 like this. There's the 2nd car. Okay, kind of weird looking cars, but that's okay. And they're going different speeds. So let me see the speeds again. So 1 is at, where'd it go? 1 is 80 and the other is 96, okay? So we'll call this one 96 kph and this one 80 kph. And at some point, they're going to be this far apart. How far apart? Let's see, 528 kilometers apart. 528 kilometers. Find T. Okay, so at what time? Now, a couple of things. Notice they're different speeds. They travel different distances, and but they do travel the same time. Does that make sense? The time is the same for both of these?
So the time is the same and the total distance is the same.
The total distance, right? Okay, but let's see how that plays in. Okay, so here we can still make a table to help us organize this one. So hang on. I'll just call it fast and slow. And you also want a total down here. Okay. So, and then across the top is our system, is our relationship. The rate times the time is equal to the distance. Okay, good. Okay, there I got my table all organized. Now I'll fill in what I know. Okay, so the rate, so the fast one is at 96 kph, the slow one is at 80 kph, and I don't need anything there. Okay, the time is the same for both of them, T. Okay, and we know that the total distance is 528. I'll put that down there because that's the total distance. Okay. They both go different distance, but the total one, when I add the 2 together, that's how far they go. All right. So what do I have? So now look, I just follow this across. So this times this is equal to 96T. This times this is equal to 80T. And can you see where the equation is? Actually, we only get one equation, but that's fine.
That was my issue. I didn't know if we had to
No,
have
there
two.
is actually two equations. Here's one, here's one. That's what I did to find the in term over here when I completed my table. But now here's my system solving equation is right here. And that's all I need. I mean, if I can set it up and in my table, I only get one, as long as there's one variable, if it's one equation, one variable, then I can solve it. So then here we'll get 96T plus 80T is equal to 528. Okay, so then that's 176T is equal to 528. So T is equal to 528 divided by 176. T is equal to, let's see what it is.
3.
Oh, does it come out to be 3?
Yep.
Excellent. Okay. 3 what though?
Hours.
Hours, right. Okay, great. So that was I put that in there because it was sort of a different take on the motion problem. And, you know, if you get used to just filling in the boxes to complete your system and then following the system straight across to the right-hand side, then it just falls right out. No muss, no fuss. Okay, that's the important thing of putting the system, whatever your relationship is, putting that across the top in reverse order. So what it's equal to is in the right-hand column over here. Okay, good. That was a good one. Thank you. All right. Okay, everybody ready to start some new stuff? We got to advance on into solving this 3x3 system. Okay, because that can get a little tricky. So we're going to pick it up over in, I think we left off with example 3 on page 534. Example 3 on page 534. We're now in 8.4. So let's take a look at that. Okay. And keep in mind, especially with these 3x3 systems, one person decides to eliminate the Z. Another person on the same problem decides to eliminate the X, but they still get the same solution. So that just points out the fact that there's more than one way to solve these, especially the more number of variables you get, the more number of equations, the more number of ways there is to solve the system. All right. So let's take a look and see what we got. Okay. Here we go. There we go. There we go. Okay. There we go. So I can just write that a lot simpler. I'll just say 3x3 system. That's what we're doing. So we already saw our method. So let's pick it up with example 3 on page 534. Okay, good. So once again, I'm going to write down the system in standard order, making sure I line everything up. All the X's, all the Y's, all the Z's, everything's lined up. So the first one I got is 4x minus 2y, number one. 4x minus 2y minus 3z is equal to 5. And the second one, I have negative 8x minus y plus z is equal to negative 5. And 3, I have 2x plus y plus 2z equals 5. 2x plus y plus 2z equals 5. And I put a line under it. That's my original system. So I'm looking at this and thinking, what would be the easiest variable to solve for? Or the easiest variable, excuse me, to eliminate? What do you think? Which one?
All the Ys.
The Y's, yeah. And why'd you pick Y's? Because right here, they're opposites.
You could start up.
Yeah, absolutely. So that's the place to start right there. Right there. That's what I'm going to eliminate, and that's why. Right there, I'll circle it so you can see it. Okay. So what I'm going to do over on here on the side, I'm just going to add 2 plus 3. 2 plus 3. And that's going to give me new equation 4. Okay. So here I have negative 8 plus 2 is negative 6x. My y's cancel out. Plus z plus 2z is plus 3z is equal to negative 5 plus 5 is 0. I got a 0. Is that okay? Yeah, sure. 0 is a legitimate number, just like any other number. In fact, I got a whole thing like this that I won't get into right now. 0 is our most important number because it has more jobs than any other number. So 0 is a good number right there. I love it. Okay, so now notice that using 3 and 1, I can eliminate y again. Okay, so I'm going to go and I'm going to say what I'm doing over here on the side. So I'm going to go 2 times 3 plus 1. And that will give me new equation 5. See what I did over there? 2 times 3. So my equation, I just put a circle around. But I'm multiplying it by 2 right here. So 2 times this one plus that one. So 2 times 2 is 4 plus 4 is 8x.
8x plus z equals 15, right?
Say again?
It would be 8x plus z equals 15.
Well, I don't know. Let me get there. So now I got, you're getting ahead of me.
Sorry.
2 times 2 is 4 minus 3 is plus z, like you said, is equal to 2 times 5 is 10 plus 5 is 15. Okay. And I'll put a line under that. So I've gone from a 3 by 3 system to a 2 by 2 system by eliminating that y variable. Excellent. So now I just figure out, what variable am I going to eliminate next? What do you think? Notice this one's opposite signs. So that's tempting. However, 6 and 8 are not multiples of one another. So I would have to find a common multiple in there. So the first common multiple of 6 and 8 is 24. So that means I would have to multiply that equation by 4 and that equation by 3. Let's look at this one over here. But notice this one is real easy. So here, 1 and 3, so they're multiples of one another. So all I got to do is multiply equation 2 by negative 3 and then add the 2 together. And that's a little bit easier than multiplying these 2 right here. All right, so I'm going to say what I'm doing over here on the side. So I'm going to go negative 3 times 5. So that will give me -3 times that is 24x minus, oh, it's -2 minus 24x minus 3z is equal to -45. That's okay, not bad. And then I'm going to bring down equation 4. So I'm going to bring it down again instead of trying to go across like this. So I got -6x plus 3z is equal to 0. I'll put a line under that. Notice each time I'm sort of manipulating the system to make what's called an equivalent system. Equivalent system. And that means it's the same system written with slightly different numbers, but they're the same. Okay. Now I'm just going to add 4 plus 5. 4 plus 5. So when I add these two together, I get -30x. Oh, that's a nice number. There's those cancel out is equal to -45. Okay, so here x is going to be a fraction. So x is equal to, notice it's going to be -45 divided by -30. So it will be positive. So I'm going to have 45 over 30. So let's see. Looking ahead at common factors, 45 is 5 times 9. Okay. 30 is 5 times 6. Oh, of course, 15. What a bonehead. So this is, this will be 3 times 15. On top, that's 45 over 2 times 15. On the bottom, that's 30. So now my 15s cancel out and I end up with 3 halves. So here I end up with a fraction answer. Whoops, hang on. Okay, so now I'm going to go back into my 2x2 system.
Wait. I have a question. How did you get the -3 right there? I'm sorry, I missed that. -3, 5.
Oh, right here.
Yes.
I multiplied equation 5, this one right here, by -3. So -3 times +8 is -24x. -3 times +1 is -3z is equal to -3 times 15 is -45.
Thank you.
Okay. All right. So now I got a fraction answer. So I think I'm going to go down to equation 5 right here to solve for z. Okay. So let's do that. So we'll go back up here and go to equation 5. And I get right here, this one right here, equation 5. So I got z is equal to 15 minus 8 times x, which is 3 halves. Okay, everybody see what I did? So I subtracted the 8x from both sides right here. So I got z is equal to 15 minus 8x. And so for x, I put in 3 halves because that's what we solved for right there. Okay, so now we'll simplify that. So 2 goes into 8 4 times. So z is equal to 15 minus 12. Z is equal to 3. Okay, good. So now I got 2 parts of my solution. Let me try and get out of the way here. I cannot move, I'm trapped. Okay, so I got down here, x is equal to 3 halves, and up there, z is equal to 3. Okay, so I'm going to pick something in my original system here. So which equation in the original system would you pick to solve for x?
3.
Yeah, I'd pick 3 too, because there it's 2x. So, and it's y and 2z. So all the numbers are easier right there. So let's do that. So then I'm going to pick, and notice I'm saying what my equation I'm using every time. So I'm using equation 3. So I have, I'm solving for y. So I get y is equal to 5 minus 2x, which is 3/2, minus 2z, which is 3. Okay, so that was a nice easy one because x was +1 for a coefficient. So now it's just arithmetic. So solve that. So here the 2's cancel out right there. So y is equal to 5 minus 3 minus 6 is equal to 5 minus 9. So y is equal to -4. So now my solution, x, y, z, is equal to x, which was 3/2, y, which is -4, and z, which is +3. And I'll put a box around it. So that's my solution. Okay. So the one of the keys about solving 3x3 systems is keep it simple. Use the easiest combinations that you can see. All right. And just make sure you label everything that you're doing. So every time I used a new equation, I said what it was. If I used a new equation or one of the ones that I figured out, like equation 5 there, or one of the original equations like equation 3 right there. So I'm saying what I'm doing every time and the equation that I'm using. Okay. So what does that mean? So that means be organized, be systematic, and keep it simple.
Professor, quick question.
Sure.
Sorry, I know I'm behind, so sorry if this is super simple, but after you did 2 + 3, when you did the 2 times 3 + 1, you know it's multiplied because you didn't circle it, so you know it's not like you're not using equation 2, you're just multiplying by 2. Is that correct?
Hang on just a minute.
Yeah, no worries.
Okay. So there's some keys. Be organized, be systematic, and keep it simple. Okay. So drop back to your question. I'm sorry, what was it again?
So back on the left side, after you did equation 2 + 3 to give you equation 4,
Uh-huh.
the next one below that, when I first wrote it down, I took it as equation 2 times equation 3, but it's just,
It is.
The
It's
number-
3 times 3.
is it just a number or is it equation 2 times equation 3?
This is the number 2.
Okay, so
times equation 3. Anytime I write down an
circling.
equation, I put a circle around it.
got it, got it.
The
Okay,
circled numbers are always equations.
got it.
The
Cool.
the author doesn't do that in the book. Bad author, bad author. Okay. In fact, the author rarely numbers the equations. Well, he puts the numbers in parentheses. Okay. I like just a circle, keep it simple. And then if I'm going to multiply it by something, I just put that as a regular number outside of the circle.
Got it. Okay.
Okay. So right down here, it's -3 times equation 5. And then I'm adding 4 + 5 down here. Okay. So let's do another one. So this next one actually has some missing terms in it. Good. Let's take a look at that. Hang on here. There we go. Okay. All right. Okay. That's good. Better. Okay, so this is example 4 on page 534. Okay. Hang on, let's see what we got here. So once again, I'm going to write down my system. And it's important, even with missing terms, you want to keep everything lined up. Okay, so let's take a look at the system. So here's equation 1. And I have x plus y plus z equals 180. Oh, nice. X plus y plus z equals 180. 2, I have x minus z is equal to negative 70. X minus z equals negative 70. And notice how I'm just leaving a space in there where the y is. The y is missing, but I'm lining up the x's and the z's. And then I got 2y minus z is equal to 0. So 2y minus z is equal to 0. So 0 is a number. It's not a missing term. There's my system. Okay, so I left spaces where the numbers were missing. But I'm going to use this. I'm going to do the same thing. And think about what would be the easiest variable to eliminate here. I'm going to do the same thing. Let's see. Oh, hang on just a minute. Well, let me back up one. Yeah. So which variable would be the easiest one to eliminate, you think?
Z.
That's what I'm thinking too, the z, because they're opposite terms right here. Okay, so I can use, I forgot the number of this equation. Hang on. 3. So I can use combinations adding 1 plus 2 and 1 plus 3 to eliminate the z. And that'll give me a 2 by 2 in x and y. So let's do that. So the first thing I'm going to go 1 plus 2. And that'll give me new equation 4. 1, 2, 3, 4. Okay, so adding these two together right here. So I get 2x plus y, z's cancel, is equal to 110. Okay, then I'm going to add 1 plus 3 and get new equation 5. So I'm adding this one plus this one. So here I got x plus no x is x. I got y plus 2y is 3y. And that's equal to 180 plus 0 is 180. Okay, so there's my 2 by 2 system. All right. Now, I look at that and say, okay, which one would be the easiest variable to eliminate? What do you think? I'm thinking the x, okay? Because the numbers are smaller and I only have to multiply by -2. And up here I multiply by -3. Not that I can't handle a -3, but I'm going to stick with the -2. Some people might eliminate the y. That's okay too. I don't know what the author did. Let's see. Let's see. What did the author do? I can't even tell what the author did. Oh, the author eliminated the z first and then the y second. Oh, the author used substitution. Again, you can use substitution on this too. Notice I can solve both of these for equations in x and y, and then I'll have a system in x and y, just like this right here. But I'm going to stick with our present methodology right here. I like it. So I'm going to go -2 times equation 5. -2 times equation 5. So -2 times 1 is -2x. -2 times +3 is -6y is equal to -2 times 180 is -360. Okay, good. And then I'm going to bring down 4. Don't try and add them across like this because you'll get your numbers mixed up. So actually bring it down and make another set right here. So I'm going to bring down 2x plus y is equal to 110. And I'll put a line under that. And now right here, I'm adding 5 plus 4. There we go. Okay. So negative 2x plus 2x, x's cancel out. Excellent. Negative 6y plus y is negative 5y. And I'm liking that a lot. Why do I like that a lot? Because my number over here ends in 0. And 5s always divide evenly into numbers that end in 0 or 5. So just sort of looking ahead. So now that I'm going to equal these two will add up right here. So I'll get 3 minus 1 is 2. 6 plus 1 is 7. 0. 270. Notice you can multiply back. So there's 0. Now, wait a minute. Did I do that right?
I think you mean 250.
Huh? Here, when I add them together, negative 3 plus 1. Oh, it's negative 2.
Yeah, -2.
Okay.
Yeah, and then
Yeah,
just
easy it is
one.
to make a sign error. Okay. And then 6 plus 1 is 7. 0 plus 0 is 0. Okay, good. And so now I can solve for y. Notice I'm going to divide a negative by a negative. That's a positive. So y is equal to 270 divided by 5. So y is equal to 54. 54. So 5 goes into 27 5 times, has 2 left over, and 5 goes into 24 times. Okay. All right. So we got
I have a
one.
quick question.
Yeah.
How come
Yeah,
it
yeah,
wouldn't
question.
be 250? Why is it
Sorry, say
2?
again?
Yeah, it's 250.
Yeah, it's 250.
What's 250?
So 360 minus 110 would be 250.
Oh,
Yeah, that's what I was
I-
trying to say. Yeah.
you see what I did? See the
Yeah,
mistake?
yeah,
I
I
made?
see what you did. Yeah.
I just added the digits
Yeah.
instead of subtracting the numbers, taking the difference in the two numbers. Oh, thank you
That's
very
so good.
much. But you can see how easy those mistakes are. So that was a basic arithmetic error. And I'm glad you pointed it out. I could say I did it on purpose just to see if you were paying attention.
I
But
think you were.
I didn't. Okay, so let's take a look at that again. What was your question, Kendrick? Did you have a question?
No.
Kendrick? Okay, so let me finish this right here. So here I got negative 6 plus 1 is 5y is equal to the difference between 360 and 110, which is going to be minus 250, as you said. Okay. And this is negative over here also. So y is equal to 250 divided by 5. So y is equal to 50. All right, so we got one of our answers, y equals 50. Now I'm going to go back in here into my original 2 by 2, which is this one right here. Don't go into this one right here. Go into the first one, and I'm going to solve for x. So it looks like I'm going to use equation 5 because the coefficient of x is plus 1. So I'm going to use equation 5 over here, and then I get x is equal to 180 minus 3y. 180 minus 3y. So x is equal to 180 minus 3 times 50. So x is equal to 180 minus 150. So x is equal to 30. Okay, so now I got the y, I got the x. So now I'm going to go back into my original system. So what equation in the original system would you use to solve for z?
Why did you go back to 5 instead of just going back to 3? Is that just a personal choice, or does that
Not just
actually
personal
affect it?
choice. I could have gone back to 3. You're correct. And notice just looking at it, I would get the same answer.
Okay.
Would I get the same answer? I don't know. That's a good
Yeah.
question. Oh, instead of going to equation 2, you mean?
Like how you just went to number 5 instead of taking y equals 50 and going straight back into number 3 to solve for z. Does it matter?
No, it doesn't matter. Notice I could have gone back here to solve for x and back here to solve for excuse me, I could have gone back in with Y. I could have gone back in here to solve for Z. And then with Z, I could have gone back in here to solve for X. Okay?
Okay,
So
thanks.
what I said before, there's more than one way to solve these. But I'm sticking with my methodology. And my methodology was to solve the 2 by 2 and then go back into the original equation to solve for the third variable. I mean, that's me. Okay, but if you go that other route, that's okay too. So let's go back to equation 1 and we get solving for Z now. Z is equal to, now I could go back into either one of these and solve for Z using X or using Y. Okay, but I said I'd do equation 1. Okay, so I'm going to do that. So I get 180 minus Y, which is 50, minus X, which is 30. So I get Z is equal to 180 minus 80 is equal to 100. So my XYZ is equal to 30 and 50 and 100. And notice if I add those three up, I get 180. So once again, there's more than one way to approach this problem. Okay, what the author did in the book is he solved these two equations for X and Y in terms of Z, and then he substituted them back into equation 1. Okay. Anyway, there's more than one way to solve it. All right. So what you got to do is be flexible, be organized. So right over here, my 3 key things for success, right here. Be organized, be systematic, and keep it simple. Am I showing you that? Yeah, there you go. Be organized, be systematic, and keep it simple. If you stick with one way, then follow that way through. You can always go back and do it another way to check it if you want. All right. Okay. This side. Oh, no. So any other questions on that one with the missing terms? Pretty straightforward. Let's see.
I just have one quick question.
Yes, go ahead.
When you solve for Y at the bottom, is there a reason it went from negative 250 to 250? Should it be negative 250 divided by 5?
I don't understand your question. Say it again. Oh, why the negative changed to a positive?
Yeah, for the fraction.
Oh, because it's a negative divided by a negative, and that's going to be a positive. So I
Okay.
just dropped the negative signs right there.
So to get the 5 from the other side, you times negative 5 to get it over. And then when they're both negatives, it turns into a positive.
Yeah.
Okay, cool.
But keep in mind, okay, what we're doing is we're trying to, I don't know, be as efficient as possible. Try not to move as many negative signs as we have to, because it's easy to make sign errors. And so I'm just using basic arithmetic techniques for solving linear equations that that you developed probably a couple of semesters ago, like in an earlier algebra course. So here I'm just, in my mind, I'm dividing both sides by -5. And so that ends up right here. They're both negative, so that'll be a positive. So I just wrote 250 divided by 5 is equal to 50.
Okay.
Okay. All right. So hang on just a minute. Let me see what's next right here. All right. Okay. So let's talk about the different types of systems. Okay. So as in a 2x2 system, I can, and don't don't worry about what these look like geometrically, because this is a three-dimensional system, which means that each one of these doesn't represent a straight line. It represents a plane in the 3x3 system. So, and the author shows pictures of them there. You can take a look at the pictures in the book, but I don't want you to get all excited about the geometric layout that these represent. We're going to keep our knowledge of the three basic types of systems that we can come up with the same as they were in a 2x2 system. So I'll have a consistent system, I'll have an inconsistent system, and I'll have a dependent system. And then we'll look at examples of how each one of those will fall out when you're trying to solve the system. Okay, so let me go over and we're going to write that down. Okay. Where you will really get into this is if you take a course in analytic geometry. So in analytic geometry, you'll get into 3x3 systems. And typically where they'll get into this is in calculus, Calc 2 and beyond. Okay, calculus 2 and beyond. So all of our geometry is just going to be 2x2, two-dimensional systems. All right, so hang on just a minute. Let me get my notes over here. All right. So now we're going to look at, this is actually, hang on just a minute. Let me tell you where we are. So we are over at objective C on page 535. So this is 8.4. Yeah. 8.4 objective C. Okay. Where we are talking about now, these notes up here. Types of systems. Okay. So my first type of system I can have right here is a consistent system. Consistent system. So in a consistent system, it's we got it, all of these represent intersecting planes, but in our consistent system, we're going to have one XYZ XYZ ordered pair or ordered triple, excuse me. And then we could have two and inconsistent. And what they all represent intersecting planes. Okay. Two is an inconsistent system. So what does that mean? So N means not, it's not consistent. So what we're going to end up here is no solution. Or once again, the X, Y, Z ordered triple is equal to the null set. Remember that's the null set right there? I'll write that down again over here. Null set. And all that means is the solution set that doesn't have anything in it. because there's no solution. Okay. And finally, we could end up with a dependent system. Okay. So in a dependent system, we're going to have one line or one plane. We'll have an infinite number of solutions. Which are represented by one plane. So in a 3x3 system, each of our equations represent a plane in the three-dimensional coordinate system. So just as in a 2x2 system, each one of the equations represented a straight line in a 2x2 system. So if you had a dependent system, that means it was the same line. So over here for a dependent 3x3 system, that means they're all the same plane. Okay, so there's an infinite number of XY ordered pairs, but they all have to satisfy the one plane. And again, we'll write it in set builder notation. So we'll go over how we write that again when we get there. Okay. So first we're going to look at an example. So we've already seen examples of consistent systems, which we worked so far, where we get one XYZ ordered triple. But let's take a look at an example of an inconsistent system. So this is example 5. I'm not sure it's the same example. Yes, example 5 over on page 536. Make sure I wrote it down here correctly. Yes, yes, yes. Yes, yes, yes. Yes, yes, yes. Okay, good. Looks good. Okay. Now, we don't know it's an inconsistent system. Looks like just any other system to us. So let me write it up here. So our first equation right here, we have y plus 3z is equal to 4. Hang on just a minute. Let me go over this way a little bit more. 1. Boom. Y plus 3z equals 4. I just left myself a little more room because I didn't want to come into this area here with my operations. Then equation 2 is negative x, negative y plus 2z is equal to 0. So then we have negative x, negative y plus 2z is equal to 0. Once again, you can see how I'm lining up all my x's, y's, and z's. I left an open space right there because there's no x in that first equation. And then number 3, I have x plus 2y plus z is equal to 1. So we have x plus 2y plus z is equal to 1. And there's my system. Okay, so once again, I'm going to do the same thing I did before. I'm going to look at it and see which would be the easiest variable to eliminate. Notice if I add these two together, I'll have an equation in y and z, and I have one up above too. All right, very cool. So that's good. So a lot of times missing terms make it easier to solve. So I'm going to eliminate this pair right here. So I'm going to go 2 plus 3, and that's going to give me new equation 4. So when I add those two together, those go away. Minus y plus 2z is plus y, or plus 2y, excuse me. 2z, that's right, yeah, 2z plus 1z is plus 3z is equal to 0 plus 1 is 1. Okay, good. And now I'm going to bring down equation 1. Equation 1, I got y plus 3z is equal to 4. There's my 2x2 system. Okay, so I don't recognize anything yet. I haven't seen it. I can see it, but maybe you can't. So let's eliminate the y's. So I'm going to go -1 times 4 plus 1. -1 times this one plus that one. So -1 times y is -y plus y is 0. Huh. -1 times plus 3z is -3z plus 3z is 0. Huh. That gives me a 0 on this side is equal to -1 times 1 is -1 plus 4 is +3. So notice what I got. I got 0 over on this side plus 3 on the other side. Is that a true statement? Does 0 equal 3? No, 0 does not equal 3. So this is a false statement. Because 0 does not equal 3. So it's a false statement. So therefore, there is, we can represent the answer in 2 ways. 1, there's no solution. Or if you really want to be algebraically technical, you can say 2, the x, y, z ordered triple is equal to the null set. You could say either way, but realize that that's how you might see it if someone's helping you out or you Google it on the internet. Okay, or you might just see no solution. All right. But the way we know it's that is because we got a false statement. So anywhere in the solution process, if you get a false statement, immediately you can stop what you're doing and just write, hey, no solution. Okay. Let's look at another example of a consistent system. So that's example 5. Go over here. Oh my, okay. It's break time. So we're going to take 10. Okay. I'm going to put us on pause. We'll take 10 and then we will come back. So the time now is 8:18. So we'll come back at 8:28. The math train will leave the station and then we'll do this another problem here. So let me put us on pause right here. Yeah,
When you said
why
hello,
didn't you tell me? You knew that.
Yeah, I do that. Yeah, I know. I just didn't say shit. I'm sorry.
Okay, but we only worked one problem. No, we worked 2 problems, right? Do we work 2 problems or 1 problem? Okay, just let me rehash real quickly. Yeah, we did work 2 problems. Okay, because we started 8.5, 3x3 system word problems using keywords, translate sentences to equations. Example 1 was a pure number problem where I just wrote down simplified version of each of the equation statements or each of the, that's right, each of the statements in the word problem. So the first one said the sum of 3 numbers is 4. So I key on the equal sign word, x plus y plus z equals 4. And that gives me an equation. The second sentence said the first minus twice the second minus the third is 1. Okay, so again, I key on the equal sign word. So I get the first x minus twice second minus 2y minus twice third, or minus third minus z is equal to 1. Second equation. And then the third one said twice the first minus the second minus twice the third is -1. So that says 2x minus y minus 2z equals -1. And then I solved that 3x3 system. So you can see the solution for the 3x3 system here. And we actually solved this in the previous section in 8.4, where it was just given to us in all the equations were given in standard form. But here we had to get them by translating keywords. So again, when you translate keywords, you concentrate on the equal sign word, and then you just look at other words that mean mathematical operations. Okay, and just write down the sentences real simply. You don't have to put articles in there. You don't have to write the word number. We're working with numbers. So I just wrote first, second, third, and then the mathematical operation that tied them together. Okay, where twice means 2 times, minus means subtraction. And then we solved it right there. And so we got one XYZ solution. Okay, good. Okay, so the second one we just worked was a geometry problem, and this was example 2. And the first thing, anytime a problem involves a geometric figure, what you want to do is draw the figure. Just make a very simple version of it. So there's a triangle. It was a triangular cross section. And then I labeled each of the angles, X, Y, Z. Okay, you can call them A, B, C if you want. It doesn't make any difference. I just use X, Y, Z because typically that's what we use. And then I said, okay, X is the small one, Y is the medium, and Z is the large one, because it all referred to small, medium, and large in the statements in the problem. Okay, so the first statement said the large is 70 greater than small. Large is 70 more than small. So there I get Z is equal to X plus 70. Again, I'm keying on my equal sign word right there, the verb of being, the verb is. Then the second sentence says large is twice remaining. Okay, well, I talked about large and small here. So the only remaining angle is Y, the medium size angle. So I go Z equals 2Y. And then the last, we didn't have another sentence that was given to us. So we have to know a property of triangles. And one of that properties of triangles is that the sum of the angles is 180 degrees. So that means X plus Y plus Z equals 180. Okay. And then I wrote my system up there, starting off with the first one, X plus Y plus Z equals 180. Then 2, I got Z equals X plus 70. 3, I got Z equals 2Y. Right here. I didn't put them in standard form because I realized, oh, if it's like that, I can solve for X in terms of Z, and I can solve for Y in terms of Z. So that's what I did on the next in the next set down here. I took equation 2 and I go X is equal to Z minus 70. Equation 3, I go Y is equal to 1/2 Z. Now I can solve it by substitution. So I substituted into the first equation, X plus Y plus Z equals 180. Notice how I use parentheses to substitute. Very important. Always, always, always. 100% of the time, use parentheses to substitute. That's going to help you eliminate sign errors. And then I got one equation in Z, which I saw. Good. And then I just went up there and showed the other solutions just visually for X and Y. Okay, good. And that brings us up to date. Okay, so whoever reminded me, thank you very much. All right. How are we doing? Oh, we're doing good. Okay, good. No sweat. Okay, so what do we got next? So now we can do, I think the next thing is a value mixture problem. Yes, it is. Is that
I
right?
have a quick question, Professor.
Yes, we got a question.
Could you tell us again how you got 5/2 from 2/2?
How I got what?
How
Oh,
you
5/2 from 2 1/2.
Yes.
Okay, so this is converting here. Let me go over here where I have more room, I think. Let's see. No, I don't have any more room over here. Okay, hang on. Let me clean this up. So in our Arabic numeral system, that's what we have. We have what are called mixed numbers. In the decimal system, you don't. You don't have mixed numbers in the decimal system. Unfortunately, we do. So we have a mixed number. Is equal to an improper fraction. Now, all improper fraction mean is that the top number is larger than the smaller number. Okay, that's all it means. A regular fraction, there's proper fractions and there's improper fractions. So not that there's anything wrong with the fraction. It just means the top number is larger than the smaller number. So in our example that we looked at, we had 2 1/2 is equal to 5 halves. Okay, so the way I got that is with the 2 1/2, this is equal to 2 times 2 plus 1 over 5. Okay, so that's equal to 5 halves. 4 plus 1 is 5 over 2. Let me give you another one. So here, I'll make one up. So here is 3 1/5. Okay, so this is equal to 3 times 5 plus 1. Actually, it's easier if you go this way. Start here. And so it's 5 times 3 plus 1. So it's this number times that one plus that one over 5. So that's equal to 15 plus 1 is 16 fifths. So that's how you change them. Okay. Yeah, everybody got that? That's important because in our Arabic system, Arabic numeration system, we deal with fractions and mixed numbers. In the decimal system, you don't. That's why the decimal system is so nice. I don't deal with those things. Okay. Unfortunately, we have to. All right, good. Did that answer your question?
Yes.
Sebastian? Okay, good. That was good, though. People need to know how to do that. Okay, so we're going to look at another example here. And this next example is going to be a value mixture problem. Let me see if it's the one I'm thinking of here. Okay, no, I'm not going to work the next example because the author threw a curveball at you that we didn't cover. So hang on. What I'm going to do is do one out of the setback here. Okay, good. Yes, that's what I'm going to do. So we're going to work is problem 18 out of the exercise set. All right. I think that's what I did, didn't I? Yeah, problem 18. That's what I want. Okay, good. Hey, we're doing good. So this is problem 18 out of the exercise set. So it's 8.5, number 18. I'll kill myself here before the night. So this is a value mixture problem. Okay. Let me come back over here. Let's see. Okay, good. So let me read it. Okay, so this one says Chick-fil-A, that restaurant, recently sold 14-ounce lemonades for $1.49 each, 20-ounce lemonades for $1.69 each, and 32-ounce lemonades for $2.05 each. During a lunchtime rush, Chris sold 40 lemonades using 6 1/4. Oh my goodness, there's another mixed number. 6 1/4 gallons of lemonade while collecting while collecting a total of $67.40. How many drinks of each were sold? You go, "Oh, man, come on. What do you think I am anyway?" Okay. Never mind. Someone's calling, but I can answer it later. Okay. Okay, so once again, we can use the value mixture, the cost equals the price times the amount to help us set this up. Okay. And so we're sort of going to use a combination of that and the number problem, but we'll concentrate on that. So here, I think we can make a table to solve this problem. If we don't get through with it, we'll finish it up next time. So we got our items. And what are my items? Small, medium, large. Okay. No, wait that second line. Hang on. Looking good. Okay, so this is the amount times the price equals the cost. Okay, so here are my variables. I'm just going to go S, M, L, small, medium, large. Okay, and I know the price of each. So they told me the price. So hang on. So the price is, the small one is oh, they're 40, 20, 14, 20, and 32 ounces. Okay, 14, 20, 32. I'll just put them in numerical order, small, medium, large. So the small one was $1.49. And then the medium was the 20 ounce one, and that was $1.69. Okay. And then the large one, that was the 32 ounce one was $2.05. Okay. And then I'm not going to put anything here. Let's see. Then I'm going to just follow this across like this. Okay, so here I'll have 1.49 S, 1.69 M, and 2.05 L. Okay, now I got things down here too. So did we know how many drinks they sold? Well, let's take a look at it again. So we sold, Chris sold 40 lemonades. 40 lemonades. So 40 total drinks right there. This should be total down here. Total right there. Okay. And how much money did he make? Let's see. 40 lemonades, collecting a total of $67.40. Okay. So notice right here, I have two equations. So here's one. And then here's my other one right here. Okay. Oops, hang on. Yeah, so let me write those down. So number one, I got small plus medium plus large equals 40. And number two, I have 1.49 small plus 1.69 medium plus 2.05 large is equal to 67.40. Okay, so I got two equations, but I need a third equation. Okay, and the third equation, you sort of got to think about the problem a little bit. So for the third equation, I got to think about how much he actually used, because they give me some more numbers in here. Notice it says, I know the size of each one. So the small one is 14 ounces. The large one, or the medium one, is 20 ounces. And the large one is 32 ounces. Okay. Then he says he used 6.5 gallons of lemonade. 6.5 gallons of lemonade. So what we need to know is how many ounces are in a gallon. Let's see, I wrote it down in here.
How many ounces in the what? Gallon?
128 ounces per
Sorry,
gallon.
Say again. Say again, how much?
128 ounces per gallon.
Is that right?
Well,
128 ounces?
it's just saying it here on the book.
Oh, okay, excellent. Thank you very much.
Yeah, and it's
Oh,
six
it
and a
does say
quarter.
1 gallon is equal to 128 ounces.
Yeah, and
Very
it's a
good.
6
Thank you for
1/4,
paying
not 6
attention.
1/2.
Okay, so that's how we get our third equation. We probably aren't going to have enough, but we'll be able to get our system anyway. So the third equation, I'll write the system up here, but let me put down the third right here. So we know that, so how many ounces is small? It's the number of smalls that you sell times 14. So then I got 14 S plus, what was the next one? 20 M plus 32 L is equal to 6 1/4 times 128. Okay. So I have some higher math over here. So that's going to be 25/4 times 128, and 4 goes into 128 32 times. So it's going to be 25 times 32. So someone multiply that out. And I'm going to write my system up here. Someone figure out what 25 times 32 is. So our system then, we'll have to solve this next time. But I get S plus M plus L is equal to 40. And then 2 is a little more complex. So 1.49 S plus 1.69 M plus 2.05 L is equal to 67.40. Then 3, I got 14S plus 20M plus 32L equals, what's 25 times 32?
800.
Huh?
800.
Oh, it's an even 800? Oh, excellent. I love that. 800. I like nice, round, even numbers. So there's my system right there. So notice on this system, I think the first thing I'm going to do is get rid of the decimals. Okay. So the top equation I like. I'm not going to mess with that. The bottom equations. not so bad either, but I think I can simplify it. But this equation here, I'm going to get rid of the decimals. So to get rid of the decimals there, what do I need to multiply by?
100.
Exactly right. So I'm going to go 100. So number one, I'm going to bring down number one again. Okay, I'm going to go 100 times number two. Then that'll give me 149 S plus 169 M plus 205 L is equal to boom, 6,740. Not exactly liking that, but I can live with it. Okay. Now, this one here, I think I can simplify because I know there's at least a factor of 2 in all of those. So I can simplify everything by multiplying it through by multiplying it by 1/2. So I'm going to go 1/2 times 3. Then that will give me 7S plus 10M plus 16L is equal to 400. Good. All right. There, I've just simplified my system. Now we're out of time, so we'll finish solving that next time. But you can see this one's a little bit more difficult to solve because of the numbers. But, you know, maybe we can do some fudging around with this and make it a little bit easier to solve. But we'll take that up next time. So, any questions now?
If the numbers are going to be really big, can we just leave them as a decimal?
We can leave them as a decimal, certainly.
There was one of the problems that I don't remember what it was, but it was like hundreds of thousands, and it was just easier to just do as a decimal, I thought.
Yeah, I
Yeah, you can
remember
leave
that.
them as decimals. Mhm. Okay, any other questions right now? Okay, so I will send you the homework and the video later on tonight. And also remember that we will have office hours tomorrow from 6 to 6:50. I will include that also in my email to you. Okay,
Thank you. Good night.
Thank you. Have a good night, y'all. See y'all next week.
okay, good. We'll see you next week. And let's see. Okay, Dakota. Are you still there, Dakota? Don't go away.
Yeah, I'm still
I
here.
put your question right here. So what I could do is I'll send you a link to the videos of the first 2 nights.
Okay, awesome.
Okay. All right. And then we'll see you next time.
Sounds good. Hey, actually, Professor, one more quick question.
Yes.
For looking over the syllabus, for the, I believe it's folders, you call them, or
Yes, the notebook.
notebook? Yeah. Can you just elaborate on that real quick?
Okay.
What
So for the
exactly-
notebook, what I wanted you to keep is your homework and the previous test and your notes. Okay, now if
Okay.
you take your notes in a like a loose leaf, like a spiral notebook, that's fine. You can just slip it in there. But I want you to keep your homework in there and the previous test and your syllabus. So the syllabus is real important. So that has to go in your notebook also.
Okay, well,
So
each,
it's easiest just to use a simple 3-ring binder.
yeah. So it's not like one folder for each week, like it'll.
No, not at all.
it'll be
No,
the
just
same
a
one.
3-ring binder with the stuff up to that point.
Okay. Cool.
And if you're taking other classes and you want to keep them in the same binder, that's okay too. A lot of people do that. Just have it separated so I can see where the algebra part is.
Okay. Y'all probably have more questions tomorrow during office hours, but
Okay, great. Hey, thanks for showing up. I appreciate that.
yeah, thank you for letting me in. It's been a hell of a day.
I can imagine. All right. Have a good one. Have a nice rest of the week and weekend.
Thank you, you too.
Okay, bye now.
Oh, hi.
Yes, Kevin, what you
Oh,
got?
can you hear me? I just joined this class like 1 week ago. I'm not sure about the homework. Is that are we Where's the homework at? Is that like at the book that on the syllabus or?
Okay, so the homework is, I send you a copy of the homework assignment
Uh-huh.
up to that class. Each time, after each class, I'll send you a video, which will have a video that we just recorded here
Yes.
and the homework assignments. And then the homework is also included on the Canvas.
Oh, all right.
Yes,
Because
we are turning in homework on Canvas. So we're turning in the homework hard copy on the 23rd when we come back into the classroom.
but like where's all the question? Because when I checked the homework, it just like said 8.1 and some number on it. I didn't see any question on it. I'm not too sure.
Okay, so it'll have 8.1, for example, followed by a parenthesis, a right-hand parenthesis, and then it'll have the numbers. So those are the problem numbers.
Oh, all right. Got it.
Okay, and then if
Yeah.
you have any other questions, you can just email me and then I'll answer you directly.
No problem. Thank you very much.
Okay, Kevin, have a nice
Yeah.
evening.
Yeah, good night.
Good
Bye.
night. Bye-bye.